Okay, so this is what you should have gotten in the previous application exercise piece. And so we took our lm underscore fit, we piped it into the predict function, and we set our new underscore data to actually be the same as the data that we fit the model on. So we set that data to be auto. And then we piped that to the bind calls function, which binds the columns of the output from our prediction and the full data set. And so what this does is it brought this column.pred and it appended it, or it added it on to the full auto data frame. So now we've got a data frame that has the same number of rows, 392, but now it has one extra column, .pred. And this .pred column is the predicted value for miles per gallon from our linear model fit using horsepower. And we saved this using the assignment arrow here. We saved this output as mpg underscore pred. So when we run this in the console, we see this output. Okay, so now we want to calculate the error. And we've been talking a lot about mean squared error. And so mean squared error, if you remember the calculation for that is basically you're taking your predicted values and you're subtracting them from your true values in your data set, and then you're squaring those differences and taking the average. In Tidymodels, they use something called root mean squared error, which, as you may have guessed, is just the square root of the mean squared error. And so we can calculate this root mean squared error by using the mpg underscore pred data frame. And so this is our data frame that includes the full auto data as well as a .pred column with the predicted values from our linear model. And we can pipe this to the RMSE, or root mean squared error function, and we tell it what the truth is. And so the column that indicates the truth, the true y value, that's mpg in this data frame. And then we tell it what the estimate is. And in this case, the estimate is .pred. That's our estimate from our linear model. And this will output a data frame. In this case, because we're just calculating one metric, it's just going to have one row. It'll tell us what the metric is, root mean squared error. It tells us this is a standard estimator, and it tells us what the estimate actually is. And so the root mean squared error for this model is 4.89. Okay, now what is this estimate? Is this training error or testing error? So if you remember when we created the mpg underscore pred data frame, in the predict function, the new data that we plugged in was actually the same data that we trained our model on. And so we got predicted values for the same training data. And so that means that this estimate is training error. If we had used a new data frame in that new underscore data part of the predict function, then this estimate would be testing error. Okay, so now let's talk about how we can actually do what we learned about last class, this cross-validation or data splitting. Because often we don't have a second set of data. For example, here I don't have two sets of auto data, I just have the one. And so if I wanted to be able to fit this and estimate testing error, I would need to do something to split that data up. And so the first approach here would be to use that validation set approach. And so this is where you just split the data into two parts, and you fit the data or train the model on one of those parts, and then you test the model on the other part. And so as I mentioned in the previous lecture, this is called the validation set approach. And in Tidymodels, you do this using the initial split function. And so we're going to create a split object called auto underscore split by running the initial split function, specifying what data frame we want. So we want to use the auto data frame, and specifying the proportion that we'd like to use. And so in this case, I'm going to do a 50-50 split. And so I'm going to set the proportion to be 0.5. And so if I take a look at this object in R, you'll see that I end up with 196 observations in my analysis data set. So that's like my training data set. I end up with 196 observations in my assess data set. So that's my testing data set. And then total, I have 392 observations. That's how many observations are in the auto data set. So the split object basically creates a random split so that I can do this validation set approach. And then from this, I can extract the training and testing data by using the training function and the testing function. And so, for example, here I can create a data frame called auto_train by running the training function on this split object. And now when I look at that in my console, I have a data frame that has 196 rows and 9 columns. And so my original data set was going to have 392. So if I looked at the whole auto data set, that would have 392 rows. But when I've split it, this training data now has 196 rows and 9 columns. And that auto_split, every time you run this initial split function, you'll get a different split, a different auto split. So it's randomly deciding which ones should be in the test data set and which ones should be in the training data set. So these 196 were randomly chosen as my training data set. And so what I want you to do here is I want you to copy this code here and fill in the blanks. And I want you to do, there's going to be a couple of steps here. First, I want you to create the split object. And then I want you to pull out the training data set and the testing data set. I want you to fit this linear model, the one that we've specified previously. But now I want you to fit it just on the training data. And then I want you to calculate the test root mean squared error. So I'm going to give you 4 minutes to work on that. Go ahead and work on that in the same document that you had worked on the previous exercises. All right, go ahead and knit your answer and then watch the next lecture for the follow-up slides.